This video will be showing you how to find the area of the shaded region in a graph through the use of integrals. It's a fairly simple concept, and in this video I'll be giving you two separate examples. So first let's look at the general equation, which we first look at xt minus xb. And what do I mean by that? Xt always refers to the equation on the top, or the top curve, which, as you can see here, right, is this equation. Now xb always refers to the bottom equation, which, as you can see here, is this, right? And that's because it's the bottom curve. Now the upper boundary refers to the x value that we end in which that is 4, right? If you can see here, basically, if you draw that becomes 4, and we start at 1, as you can see here. So that's our upper and lower boundaries. So the upper boundary is 4 and the lower boundary is 1. And just a quick tip, typically in a question where the equations are y equals, you always use your x values as the boundaries. So as you can see here, I have made the equation, right, which is just the square root of x, which is the top equation, minus 1 over x squared, which is the bottom equation here. And I've chosen the upper and lower boundaries, 4 here and 1 there. So doing that, we get the integrals, which is fairly simple to do with the upper and lower boundaries, and you just input them here in this equation. You eventually get the fractions, right? And finally, if you do this, you get the area under the region, and it's 3.92 meters squared in this case. Alright, so this is another example, and again we use the general formula as I've explained before, and in here we choose 2x as our top equation, right, which is just this long line here. So this is our top equation, and here for the bottom equation we use x squared minus 4x, right? As you can see, it's the bottom curve, like that. And this is the equation here. And again, this is y equals 2, so we choose the x values as our boundaries, and we did so. And as you can see here, we start at 0 as our lower boundary here, and we end at 6, which is our higher boundary. And basically, if you can visualize it, it looks like that, and that is 6. Okay, so again, we just input it into the general, we get the integrals, and we just input the upper and lower boundaries, eventually inputting the values here. And of course this is 0, right, because our lower boundary is 0, so obviously this will just become 0. So we're just left with 36 minus 0, which is obviously 36 as well. And do not forget to put the meters squared, as it's finding the area. Alright, so that's it for the video. Thank you.